Okay, three problems or three sets of problems dealing with rectangles. And the definition for a rectangle is that it's a quadrilateral with four right angles. So angles A, B, C, and D are all 90 degrees. And because it is a parallelogram, if segment AB is equal to 12, opposite sides are still congruent. So segment CD is equal to 12. And because segment BC is given as equaling 8, segment AD is also equal to 8. Next problem. I gave you segment AC, one of the diagonals is equal to 30. We proved in class, because we have two overlapping right triangles that are congruent, the two triangles that I want you to look at would be triangle ADC and triangle BDC. Those two triangles are congruent, so therefore corresponding parts are going to be congruent. So if one diagonal, segment AC, is equal to 30, the corresponding part from the other triangle happens to be the other diagonal, segment BD, that's also equal to 30. And because the diagonals of any parallelogram bisect each other, segments DE and BE have to be congruent, but that means because segment BD is the same length as segment AC and you divide segment AC into two equal parts, all four of those segments end up being congruent, all of which would be half of the 30 that was given, or we've concluded for the other diagonal. So segment AE is 15, segment CE is 15, segment BE is equal to 15, and segment DE is equal to 15 because they're all congruent to each other. And if we continue and we work with the angles of a rectangle, when you draw the two diagonals, if any one angle is given, such as in this case, you have given to you angle 8 is equal to 60, we're going to conclude that we should be able to find all of the other angles. So we'll just zoom in. If this angle, angle 8, is 64, by definition, if it's a rectangle, this at point D is a right angle. So angles 1 and 8 have to be complementary, so you subtract 64 from 90, and you get 26 for angle 1. Now, once you get started, you can continue quite a few different ways. Okay, what I want to do here is I want to erase this. For example, if angle 1 is equal to 26, I can conclude that angle 5 is 26 because angles 1 and 5 form this Z-shaped figure, and the alternate interior angles, angles 1 and 5, have to be congruent because when parallel lines are intersected by a transversal, alternate interior angles are congruent. So if angle 1 is 26, angle 5 has to be equal to 26. And then angles 4 and 5 add to equal 180, so angle 4 ends up being another 64-degree angle. And we can continue quite a few different ways, but the way in which I want you to look at the diagram is this way. If we can zoom in on this, let's choose a different color. We'll pick red. See this triangle? From the previous problem, we figured out that because the diagonals are congruent and they bisect each other, all four parts of the two diagonals, meaning those segments right there, they all have to be congruent. But in particular for this red triangle, that means two sides are congruent. So if two sides are congruent, the two angles have to be congruent, being the two base angles. That gives us, if angle 1 is 26, angle 2 has to be 26. But angles 2 and 3 add to equal 90, so therefore subtracting 26 from 90 gives you another 64-degree angle. And you had angle 4 was 64 and angle 5 was 26. If you go back to looking at this red outline triangle, if two angles are each 26, that adds to equal 52 degrees. You subtract 52 from 180 and you'll have the missing angle for that red triangle, which happens to be angle 10, is 128 degrees. Now that we know angle 10, angle 12, and angle 10 are vertical angles, so if angle 10 is 128, angle 12 has to be 128, angles 12 and 11 have to add to equal 180, so if you subtract 128 from 180, you get 52 degrees. That's angle 11. Angle 9 has to be another 52 degrees, so therefore that's 52. And likewise, the triangle at the top is an isosceles triangle, so if angle 5 is 26, angle 6 has to be 26. 6 and 7 add to equal 90, so angle 7 is 64, and angle 8 was given. And it might be a mess, but we've justified each degree measure. Good luck on the exam.